Welcome to qnawire.
All right, in this problem, we are going to be looking at how to determine the number of molecules in an ideal gas by knowing the pressure, temperature, and volume of that gas. Now, there are two ways we can go about doing this. The first is just to recall our old friend PV equals nRT here for ideal gases, ideal gas law. Or equivalently, we can use one of the equations we derived when we were looking at the molecular model of an ideal gas, which was that the pressure is equal to 2/3 big N over V times the average kinetic energy of a molecule of gas, where the average kinetic energy is just 3/2 kBt. So we could just go ahead and use PV equals nRT. We'd have the number of moles at that point, and we just convert from moles to molecules. But I'm going to use the latter two equations here, just because the molecular model stuff is newer, and I think when you have new stuff, it's better to work with it more often. So if we substitute in our expression for the average kinetic energy there, we will get that P is equal to 2/3 and 3/2 cancel. So we will just have N over V K B T. And this is exactly what you would get if you solved for pressure from the ideal gas law and you converted from little n to big N. It's the exact same thing there. So now, if we solve this equation for N, we will have PV over KBT equals N. So now if we just look at our units here and make sure we're good to go before we calculate, we'll want to convert the pressure, and everything else is fine after that. So we have 1 times 10 to the minus 10th torr, and they're about 133 pascals per torr. So those cancel out. We're just left with 133 times 10 to the minus 10th pascals. And we're at a point where we can just plug everything in. So if we do that, looks like we end up getting N equals 3.21 times 10 to the 12 molecules, which actually is not very many. If you compare that to Avogadro's number, right, 6.023 times 10 to the 23rd is many, many orders of magnitude smaller. So this is a very low pressure environment here. All right, so there you have it. From knowing the pressure, temperature, and volume of an ideal gas, we were able to determine the number of molecules in that gas.